Welding joints. Welding is process of joining metals by application of heat with or without application of pressure. Advantages: highest joint efficiency, lighter in weight, easy to weld in difficult locations, less time, good appearance. Disadvantages: heat affected zone has distortion due to residual stresses, fatigue, crack propagation. Joints, permanent joint example, welded joints, like also brazing and soldering, riveted joints and reference joints. Temporary example, bolted joints, keys, couplings. Railway carriage, to carry overall coal, use riveted joints to stop fatigue crack. They use riveted joints to stop fatigue crack. Welded joint, butt tensile, fillet shear. Thin plates PPHTL experimental KT is equal to 1.2 stress concentration. Reinforcement, this extra height is reinforcement. Static load, sigma T is equal to P by T into L is equal to SYT by Fs. Actually, maximum shear stress theory should be used, but as only sigma 1 is there, Rankine gives same. Fatigue load, Goodman or Soderberg, sigma A by SE plus sigma M by SUT is equal to 1 by Fs. Thick plate H1, H3, H2, sigma T is equal to P by H1 plus H2 into L is equal to SYT by Fs. This H3 will be empty, air place. Fillet weld, G centroid of weld, L centroidal axis, both for weld and plate. GS shear stress in weld metal upper weld P is tau is equal to P by something into L at an angle theta. About this, tau theta is equal to tau BD is equal to P by T1L. This length is T1L. T1 by sine 45 is equal to S by sine of 180 minus 45. This total is S. T1 is equal to S by sine theta plus cos theta. 180 minus 45 plus theta. Tau theta is equal to P into sine theta plus cos theta by SL. Theta is equal to 0 degrees. Tau AB is equal to tau BC is equal to P by SL. For maximum shear stress, d tau by dou theta is equal to 0, dou by dou theta of sin theta plus cos theta is equal to 0, cos theta is equal to sin theta, theta is equal to 45 degrees, dou square tau by dou theta square, and theta is equal to 45 degrees less than 0, so tau max is equal to root 2 P by SL is equal to 1.414 P by SL. Fillet weld, maximum shear stress theory, tau max is equal to Fs by factor of safety 1.414 P by SL is equal to SSY by Fs. P is equal to SSY into SL by Fs into 1.414 is equal to 0.707 SL into SSY by Fs. Load carrying capacity of one weld P is equal to 0.707 SL into SSY by Fs. For two welds, P is equal to 2 into 0.707 into SL into SSY by Fs. P is equal to 1.414 into SL into SSY by Fs. Transverse fillet weld can carry normal and shear stresses, but it is assumed to fail by shear at an angle of 62.5 degrees with respect to vertical leg. Thickness of maximum shear stress plane T is equal to throat thickness is equal to least thickness in metal from root to hypotenuse. T1 is equal to S by sin theta plus cos theta. T theta is equal to 45 degrees. T is equal to S by root 2 is equal to 0.707 S. Load carrying capacity of transverse fillet weld P is equal to T into L into SSY by Fs. P is equal to 0.707 into SL1 into SSY by Fs. Transverse fillet weld can carry more load than parallel fillet weld, but conservative design its load carrying capacity is made equal to parallel fillet weld. L1 load carrying capacity P is equal to 2 into 0.707 SL into SSY by Fs plus 0.707 SL1 into SSY by Fs. Tau max is equal to sigma 1 by 2 is equal to SYT by 2 into Fs. Axially loaded unsymmetrical welds P, G, E is centroidal axis at a distance E. It is A from this side, B from this side, L1, L2. P is equal to 0.707 into SL into SSY by Fs. L is equal to L1 plus L2. Unequal lengths are taken to make bending stresses 0. So P is equal to P1 plus P2. Sigma m centroidal axis is equal to 0. P1A minus P2B is equal to 0. P1A is equal to P2B. P1 is equal to BP by A plus B. P2 is equal to A by A plus B into P. P is equal to 0.707 L S into SSY by Fs. P directly proportional to L. P1 is equal to 0.707 SL1 into SSY by Fs. P1 directly proportional to L1. P2 directly proportional to L2. L1 is equal to B by A plus B into L. L2 is equal to A by A plus B into L. Eccentrically loaded joints stresses in the weld are direct shear. Stresses in the weld are direct shear and torsional shear. If eccentrically loaded like this, direct shear and torsional shear. P wall bracket to TGW. Mx is equal to PE is equal to T. My is equal to 0. Load parallel to y axis. M2 is equal to PL. L is equal to 0. Primary shear due to primary shear. Secondary shear, it will be from G perpendicular opposite to the direction of torque. Opposite to the perpendicularly. T thickness is equal to 0.707 by 707 as tau 1 is equal to direct shear is equal to P by throat area of 2 L's is equal to P by T into L. T by T into L. Secondary shear or torsional shear tau 2 is equal to T by J into R max. A and D are critical point because if we draw combination resultant force, A is critical as theta A less than theta B. Tau R square is equal to root of tau 1 square plus tau 2 square plus 2 tau 1 tau 2 tau cos theta. As area is same parallelogram law is only applied only for this case. Tau r is function of tau 1 tau 2 cos phi. Tau r is function of cos phi for cos theta for a b c d. Tau r increases, cos theta increases, theta decreases. Theta a is equal to theta d less than theta b is equal to theta c. Tau r a is equal to tau r d greater than tau r a b is equal to tau r c. Tau max is equal to tau r a is equal to tau r d. Maximum shear stress theory, tau max is equal to SSY by Fs. Critical point is here or A only. First to find G, maximum distance from G is critical. A and F are critical. A and F are critical points carrying maximum direct shear load. Okay. Direct shear. So all polar moment of inertia. Ix is equal to 1 by 12 LT cube, Iy is equal to 1 by 12 TL cube, Ig1 is equal to Iz is equal to 1 by 12 LT cube plus 1 by 12 TL cube. But weld is treated as a line. T less than L, Jg1 is equal to 1 by 12 TL cube, Jg is equal to Jg1 plus A1 R1 square plus Jg2 plus A2 R2 square is equal to 2 into Jg1 into A1 R1 square. Gg is equal to 2 into 1 by 12 into TL cube plus TL into R1 square. Jg is equal to A into L square by 12 plus R1 square into 2. For C weld, Jg is equal to A1 into L1 square by 12 plus R1 square plus A2 into L2 square by 12 plus R2 square plus A3 into L3 square by 12 plus R3 square. Resultant, okay. Welded joints subjected to movement. Subjected to movement like this, all around fillet weld. Fillet weld is represented like this, butt weld is represented like this. This circle represents all round. She tau is equal to question mark. Shear stress tau is equal to T by J into R max. Iz is equal to integral y square dA is equal to 2 integral 0 to pi r sin theta r d theta t is equal to 2 r cube t integral 0 to pi sin square theta. Iz is equal to pi r cube t. Similarly, Iy is equal to pi r cube t. J is equal to Ix is equal to Iy plus Iz. J is equal to 2 pi r cube t. Tau is equal to T by J into R max is equal to T by 2 pi r cube t into R. Tau is equal to T by 2 pi t r square. Welded joint subjected to movement. Sigma b is equal to m by I y max. Sigma b is equal to mz by pi t r cube into r. Sigma b is equal to mt by pi t r square. Screwed fasteners. A screw formed by cutting continuous helical grooves on a cylindrical surface. Is this bolt or screw? Head, shank, thread. This is thread, shank, head. Tau, sigma. Bolted joint, screwed joint. Bolted joint, it will be like this: tapered hole, screwed joint. Nut, tapered hole, screwed joint. M DYP, M isometric, D nominal diameter, P pitch, fine thread. This is representation for fine thread. Component subjected to vibration. Application. MD coarse thread, general purpose, P 60 degrees. Screws locking purpose, power transmission. Locking purpose, BSW, British Standard Whitworth 55 degrees, British Association 47.5 degrees, ANS rough fuse 60 degrees, cutout crushed rough isometric 60 degrees. Power transmission, square threads, 0 angle. It will be like boxes, P by 2. ACME 29 degrees. Screw designation, F2 eta trough, and this lowest point is trough, this is crushed, this is flank load bearing surface. For power screw, Fa increases, coaxial force should be more. Fa is equal to F cos beta. Fa increases, cos beta increases, beta decreases. Beta is equal to 0 degrees, most efficient thread, square thread. N is equal for locking screw, N is equal to F sin beta. Beta increases, sin beta increases, N increases. Frictional force should be more. So N should be more. Stresses in screws are generated due to preload or initial tightening load, external load, combination of A and B. IC engine, preload and external load. I bolt, external load. Pressure vessel, both preload and external load. bracket to only external load, wall bracket. Stresses due to preload Fi. Cover plate, gasket, cylinder flange, cylinder. Fi bolt, connecting members Fi. T tensile stress sigma T is equal to Fi by pi by 4 dc square. Torsional shear stress tau is equal to 16T by pi dc square pi dc cube. Stress across threads tau bolt is equal to Fi by pi dct. Tau nut is equal to Fi by pi dt. N is equal to number of threads in contact. Short cantilever Fi by N dct. Crushing stress sigma c is equal to load by projected area of contact is equal to Fi by N into pi by 4 d square minus dc square. Stresses due to external load P. Tensile stress sigma T is equal to P by pi by 4 dc square. Uh, shear stress tau is equal to F by pi by 4 d square. T is equal to F into R into N. F is equal to T by Rn. These are screws F by Rn. And maximum shear stress theory, tau max is equal to root of sigma T by 2 whole square plus tau square is equal to SSY by Fs. Distortion energy theory, sigma equivalent is equal to root of sigma T square plus 3 tau square. Sigma T square plus 3 tau square is equal to SYT by Fs. External load P is equal to pressure into area of cylinder is equal to PR into pi by 4 d square. P is equal to PB plus PM. PB is equal to external load taken by the bolt. PM is equal to load shared by connecting members. Stress due to combined P and Fi. Delta V is equal to elongation of bolt due to Fi. Delta V is equal to increase in elongation of bolt due to PB. Yes, this delta M is equal to compression of connected members due to Fi. This delta M is decrease in compression due to PM. Delta V is equal to delta M, but delta V is not equal to delta M. That means due to this external load, these decrease and increase are same, but initial tightening these two are not same. Km not equal to Kb, delta is equal to Fi by K, delta B is equal to Fi by Kb, delta M is equal to Fi by Km. Km is equal to, as these are in series, Km is equal to 1 by K1 plus 1 by K2 plus 1 by K3. Delta B is equal to delta M. Pb by Kb is equal to Pm by Kb. P is equal to Pb plus Pm. P is equal to Kb by Kb plus Km into P. Pm is equal to Km by Kb plus Km into P. Stiffness factor C is equal to Kb by Kb plus Km. Pv is equal to C into P. Pm is equal to 1 minus C into P. Bolt design resultant load on bolt Fb is equal to Pb plus Fi. Fb is equal to Cp plus Fi. Sigma T is equal to Fb by pi by 4 dc square is equal to Syt by Fs. Dc is equal to question mark. This resultant load Cp plus Fi, from design we can get DC. Checking for leakage to prevent leakage, resultant load on connecting members Fm less than or equal to 0. That means it should be compressive. Fm is equal to Pm minus Fi. Fm is equal to 1 minus C into P minus Fi. Effect on preload. Effect of preload to make joint leak proof. Preload increases normal forces between surfaces and hence increases frictional force. and the prevent joint from loosening. Preload increases fatigue life of component due to reduced stress amplitude. IC engine minimum pressure is equal to 0, maximum pressure is equal to PR, minimum load is equal to P min is equal to 0, maximum load P max is equal to PR into pi by 4 D square into P. Repeated load on IC engine cylinder. FB min is equal to CP min plus Fi. So Fi. FB max is equal to CP max plus Fi is equal to CP plus Fi is equal to PB plus Fi. Fluctuating load on IC engine bolt. Load deflection KB delta V capital delta V. FB max it will go on like this delta V preload bolt. Without preload FB max is equal to constant, sigma T is equal to FB max by A is equal to SYT by Fs. FB min is equal to CP min plus Fi, both are 0. FB max is equal to CP max plus Fi is 0 is equal to P. If no preload, C is equal to 1. Repeated load. So life decreased. Eccentrically loaded joints. The stress developed in bolts due to eccentrically loaded joints as shown in figure is. The figure is this one. This will be creating primary shear as force is like this. Next, due to torque, it will rotate like this. So which will induce torsional in here bending here, torsional in primary shear and secondary shear transverse shear. PS1 PS2 it will be like this. PS2 PS1 is equal to PS2 is equal to PS3 is equal to PS4 is equal to P by 4. Then after that right, you combine these two. Theta 1 is equal to theta 4 less than theta 2 is equal to theta 3. PS1 PSR1 is equal to PSR4 greater than PSR2 is equal to PSR3. Hence 1 and 4 are critical. Finger tight joint transition fit to coupling used for coupling. Secondary shear load PS1 prime directly proportional to R1, PS2 prime directly proportional to R2, PS1 is equal to KR1, PS2 prime is equal to KR2, K is equal to proportionality constant, sigma mg is equal to 0, PS1 prime into R1 plus PS2 prime into R2, so on is equal to P into E. K into R1 square plus K into R2 square, so on is equal to P into E. K is equal to P into E by sigma I is equal to 1 to n Ri square. PS1 prime is equal to KR1 is equal to PE into R1 by sigma I Ri square. Eccentrically loaded joints load parallel to axis of bolt. Critical bolt is 2 and 4. Direct tensile load Ft1 is equal to Ft2 is equal to Ft3 is equal to Ft4 is equal to P by 4. Here as it is in this direction, it will have direct tensile load. Tensile load due to bending, because it will be in this direction bending, so tensile load again. Ft1 is equal to L1 this end from free end, L1 from free end, L2. Ft1 directly proportional to L1, Ft2 prime directly proportional to L2. K is equal to KL1 is equal to KL2. Sigma m tilting edge is equal to 0. Sigma m tilting edge is equal to P into L is equal to sigma Ft1 into L1 plus 2 Ft2 into L2. K is equal to P into L by 2 into L1 square plus L2 square. Resultant tensile load on critical bolts 2 and 4 as they are from at more distance from tilting edge. Resultant load on 2 and 4 FTR is equal to FT2 plus FT2 prime is equal to P by 4 plus KL2 is equal to P by 4 plus P into L2 by 2 into L1 square plus L2 square. PT is equal to FTR by A is equal to FTR by pi by 4 DC square is equal to SYT by FS. If relation between D and DC not given, then use D here, in otherwise DC. bolt of uniform strength, thread sigma t is equal to p by pi by 4 dc square, shank sigma s is equal to p by pi by 4 d square, sigma t greater than sigma s. Energy per unit volume, U is equal to sigma square by 2e, ut greater than us, u sigma t square by 2e greater than sigma s square by 2e. To make watt of uniform energy, us is equal to ut, sigma t square by 2e is equal to sigma s square by 2e, sigma t is equal to sigma s. Decrease in shank diameter so that area equal to thread. There are two options to make this: decrease in shank diameter so that area is equal to thread area, increase the root diameter to shank diameter, hole dia dh is equal to root of d square minus dc square, size of hole 2